So up to speak next today, we have some seats over here on your right, on my left. So up speaking today is Kelsey Hightower, who works at CoreOS, does a lot of Go, and this is particularly exciting for me because he's going to demo some of the code that I wrote last week. So this is going to be great. So without further ado, Kelsey.
So I have a new talk. I'm basically remixing this talk to talk about Nomad versus Kubernetes. And the reason for that is yesterday, like you all, I was in a keynote, and Steve Jobs walked out, or Mitchell walked out, and he introduced Nomad, and I was like, oh, that's pretty sick. Everyone should have a scheduler. And then he said it was market leading. Like it came out 20 seconds ago, and it's already market leading. So that really had me like, I gotta dig into this thing. It's market leading, I gotta figure it out. So this is my last slide, and I think the only way to examine it, I was really, really bummed out that there was no live demo. Like if you say something like that, you have to prove it. So man, we're gonna need more than demo gods today because this thing's a bit shaky, but I wanna keep everything in perspective. So even though it says versus, there will never be one thing that owns it all, right? So everyone keep that in their mind. It came out yesterday, it's 010. I expect there to be bugs, so if it crashed, it is totally where you're at. Your fault, not mine. All right, so the thing we're gonna talk about is Nomad, which is, one thing I think about a scheduler is it automates the placement of machines, usually based on resources. So it's not about just automating deployments, and we'll talk about that in a little bit. And it gives us these primitives to say, hey, I would like my job to run on a machine that has these particular aspects. And then we're going to talk about Kubernetes. I love Kubernetes, man. Kubernetes is, to me, one of the game-changing projects because I think it really forced everyone to rethink these things. And also the people that wrote the papers that are influencing a lot of these other projects have come out with their own open source solution, which is a big departure for Google in many areas, especially around infrastructure. Normally you get a white paper and you end up with something like MongoDB. And in this case, and in this case, they actually wrote this project before the new paper came out, so that was pretty interesting. And then I read this page, right? So there's some things in here that are legit, and there's some things that are like, I don't know, pretty questionable in my opinion. So one of the things, ease of use. There are multiple binaries in Kubernetes, but it takes me about the same time to provision a Kubernetes cluster that it did to provision a Nomad cluster. Unless you're doing these things strictly manually, the cost and time if you're using automation is very low. And I think long-term, I think Nomad will look a lot like Kubernetes, and I'm going to try to show why, that both of them have really good ideas. And I think there's some ideas that you just can't live without in a system like this. So in Kubernetes, I have a 3-node cluster. I'm going to do most of this presentation on the command line. Since a lot of this is new, I have this handy-dandy cheat sheet. And you guys don't judge me. I will copy and paste if I forget my steps. I don't care. All right, so the first thing we're going to do is just look at our nodes. So kubectl, get nodes. So most of these things can be done talking directly to the API. In the case of Nomad, I'm using the SSH tunnel so I can talk to the server at the end. So if you think you're going to hack me, please know that's not going to happen. Maybe I shouldn't say that because someone will own me in like 15 minutes. Don't do that until I get off stage, please. So in Nomad, we can do node status. So we have a list of nodes in Kubernetes, and we also have a list of nodes in Nomad. The output looks very similar, so I think you guys seen their project. There's no way you guys did the exact same thing. But the nice thing is we get the similar semantics. The nice thing about both systems is that the node is no longer important, right? It can become important if you really need your workload to run on a specific machine. But one thing we're going to try to do here is not log on to any of the machines to do all of our work. The first thing I want to do is talk about containers. A lot of people believe containers are just this big virtual machine that we move around with Docker and end up producing things that are about 1 gig in size. In this conversation, I want to talk about application containers, this idea that we just have a normal process that we give to Docker for convenience of distribution and the convenience of configuration. Docker does a great job at doing this across multiple platforms. So the thing we're going to be talking about today is a Hello World app. You got to have one of those when you do a demo. And this is a very simple app, but it has a couple of handlers. This Hello World app talks to Redis, and before it can become healthy, it needs to verify that Redis is alive. If Redis isn't alive, it throws a 500 back. and it can give me the version, and it can also say hello world. Very simple Go app. I'm going to use this throughout the presentation on both systems so we can compare or deploy a comparable system. So one thing we're going to do is look at the app. So it's a very simple Go app, and then what I'm going to do is build it so we can see how this thing runs. So I'm just going to build it on my Mac, and we'll run it. So hello world does the obvious thing, tell me that I need permissions for sudo to run on port 80. So it's listening on port 80. So what I want to do now is verify that it actually works. So what I'll do is I'll just do a curl on the public interface, and we'll see what happens. We know it should say hello world, and that works. And then we can see what the version is. That works. And then we can do a health check, right? So this is a common pattern called help Z, where you have a health endpoint that lets us know if the node is healthy. So if you're a developer and you do not check the status of your database before coming up and just segfault, you are a very mean person to all your sysadmins. So what I do is implement a health check like this. So my app comes up, but if you want to know it's healthy, I'll check all my dependencies and just return why I can't connect to them, right? And it helps systems like Kubernetes and Nomad because they can rely on these type of health checks to make sure the service is up. So in order to make this guy happy, we need to run Redis. So we can just do Redis server. All right, so Redis server is now running, and we do our health check, and we're good to go. So we know this binary works on our Mac, and what we're going to do is throw it in a container so we can use it in these other systems. So we'll close this off. How many of you guys, everyone in here has probably built a Docker container before, right? Some of you guys are lying, but it's cool. You want to look cool. You're at a conference, right? You don't want to be the only guy in the room that hasn't heard of Docker. I get it. It's all good. So what we'll do now is we'll build this for Linux. I always make this mistake where I do not compile my binary for Linux. So we'll do goS equals Linux. All right, and then we'll do a go build, and we'll get this binary. And our Docker file here is really, really small. Right, so this is a self-contained binary going from scratch. I have nothing in there but the actual application to do its work. That's all I need, right? Statically linked. In this case, I'll just do docker build. If I can type -t. And I'm hosting this on gRPC, or Google's container registry. And under Kubernetes up and running, and we'll call this thing hello world. Please use semantic versionings so people know what the hell version is running. Latest is not a version. We run this, we need a doc. So we upload, hopefully the Wi-Fi works here. I'm going to ask everyone to go in airplane mode momentarily. Okay, so once we build this, we now have our container that we'll be using throughout the presentation. I won't upload it in case I built it wrong. I don't want to screw up my whole demo. But ideally, you'll see that this image is really tiny, right? So this is should be about 6 megs in total, 6.7 megs. And we're going to use this throughout the system. Most of the apps I build are that small. If I use Alpine Linux or Muscle to statically link them, even in place of glibc. So once we have this, we can create jobs, right? So Nomad is interesting. So playing with Nomad is really nice. It has really nice job files. So we look at one of these job files for hello world. Here's the first thing I tried to do. So I create this thing as data center aware. And the sense that I got from those data center things, they're just like labels that have been promoted to a first class status. So in most systems, you have a way of labeling what a node does and choosing where it lands. But they've made data centers a first class citizen. Here, you also see my update strategy. So if I were to ever update this job, it will follow this strategy. So every 1 second, it will roll, doing one at a time. Here I have this group concept. And this group concept is pretty nice. It allows me to group multiple tasks. So in the case of applications, I need my hello world binary, and I need Redis to be deployed on the server at the same time. Now, they do have a flag in here that will let me do this in an atomic way to say, hey, it must happen. So you can't schedule this piecemeal. Now, this is one area that I like the way we'll see it in Kubernetes, where sometimes I actually want these to live in the same network namespace, because I'm assuming that Redis will be local to me and I can speak to it over localhost. In this world, I'm going to have to rely on service discovery, even on the same server, to find out what port Redis is on. And that can cause confusion. And it gets worse if you attempt to share data between these two containers. I don't know where to mount things, right? So I need some way to orchestrate that. But this is a way to logically group things. So I'm specifying the container that I want. I'm also doing some resource allocation, and we'll talk about why this is important. And then I'm also doing this thing with dynamic ports. So this is something kind of unique to Nomad in a sense that it treats the ports kind of like Heroku does. It tells you some environment variables, and you can bind to those ports. If you're using Docker, it will basically do the allocate some high port and proxy it into your container. So this is the first thing I tried to do. So Nomad run this job, and I got a pleasant surprise. So I got this error, right? So the error is that there are no networks available across 3 hosts, right? So there's a small bug here where it assumes that ETH0 is across the stack, and it looks at ETH0 to figure out if there's any ports or to get IP information. So if this doesn't work, but it is a good feature where it shows you there are not enough resources free. So if we did have any port conflicts, if I was trying to schedule that and I wanted that exact port, 6379, we will get this back from the scheduler immediately saying that won't ever work. There is no reason to try to deploy this. So we get this back. Now, the thing is I really don't need those ports, so I'll continue on. So what I can do instead is deploy another job, and it looks the same without the port requirements, so I run it. Now, this scheduler is pretty fast, right? And they talked about a little bit on stage, and the way that they schedule this is that they just be a little loosey-goosey and just say, hey, we know that there's a high chance that if we pick a node, by the time the workload gets there, it's probably going to run and not be out of resources. So we can move fast. We can be optimistic here. So this works, and it's pretty quick. So the next thing we do is we want to get status about this. So remember, this is a 0.1 project. So when you see this output, do not cringe at all. It's not that bad. So we call status, and then we say status hello world. And we get back a set of allocations. We get the node ID that this thing landed on. So we know that the job is running. We know that it's complete. And if we want to know what node, we grab this guy. And we can copy and paste this. So everything has all these IDs. But the thing is, you shouldn't worry about what node it's running on, but some people actually do care, like I do now. And then we'll get node status. So if we want to know what IP address or what node it's on, we see at the top that this node was elected to run this particular job. So we know it's up and running. That's pretty much what we get in Nomad today. So you get your jobs running, you can find out where they are. Now, if I wanted to talk to this pod, what IP does it have? Now you need to go on the server. And you're going to do Docker PS commands. So this is why I think the service discovery part that they talked about coming with integration to console is going to be critical. Because imagine scheduling 1,000 of these. You're not going to be able to find them. So how do we do the same thing in Kubernetes? Well, Kubernetes looks very similar. So we'll use a replication controller to deploy a Hello World app. So V1, very similar. Now, with Kubernetes being a slightly more mature project, we have some things like a replication controller. So we do not talk to the API server directly with our workload. We will say, here's a replication controller that will deploy an app with a set of labels and babysit that within our cluster. So what we're going to do here is we're going to give it a template and say, look, we will want you to deploy what we call a pod. These 2 containers will live in the same namespace, and I have some readiness probes. Don't just schedule my app and say it's all good. I need you to actually make sure that it's alive. So we can use those help Z endpoints for readiness and liveliness to figure out if the app is actually ready to go. And if the app checks out, they will be added to the service discovery framework to say these things are eligible to be discovered by a service. So what we do here is kubectl create -f. And you know the similarities here that they're both declarative systems. You write your specification down and you submit it to an API server. In this case, we create a replication controller, kubectl get rc. So we see we have a replication controller here. We have these 2 containers that make up that set, and we have a set of labels. Right now, we want a replica set of 1, which is kind of cut off on the screen there. And we say kubectl get pods. Once we get our pods, we see that we have a pod running. We get a slightly friendlier name. And once we get the pod, we can actually describe it. So once we describe the pod, we can get a lot more information about the actual running of the pod. So we see all the events that happened for this particular pod, that it was scheduled, that it fit the right size, that we found a node. And we get some high-level details about the pod. We get that it's running, we get what node it's on, we get the list of containers, we get a set of labels, we get the IP address, and we get the set of pods that are running and their memory usage within the system. So the idea here is that we should never have to log onto the server to troubleshoot any of these things. So once you have that in place, the nice thing that you can do with labels is the replication controller only keys off the labels while the system is running. So what happens is if a label comes off or the pod is deleted. You can imagine if we were to remove a label, so we'll do get pods, and we'll get rc so we can see what the label set is. And what we can do is kubectl, we can remove a label, so we can do the label command, and we'll do pods, and we'll get this pod name. And what I'm going to do is remove one of the labels. And this is great for troubleshooting. So I can say the track label, I want to remove it. I just subtract it. So what happens now is I get this report that the status has actually changed. So I do kubectl get pods. And what we see here is we now have 2 running. Because the replication controller is like the thing that meets specification is no longer there. I'm going to create a new one from the template and add it to the cluster. The other one doesn't get deleted because no one's babysitting it. If it had the exact same labels, if I add track back, it would be destroyed by the replication controller because we said 1. 2 violates the spec. Now, once it's offline, we can do things like introspect it. So since we have a central API server, we can actually redirect and talk to these pods directly without knowing what host they're on. So the first thing we can do is set up port forwarding. So what we can do is port forward. And what I want is the pod. So the one we care about, this one is out of the loop. This one's down for maintenance. And what we can do is redirect port 10,000 to port 80 on my local host. And once I have that, we get a connection going through our API server. It does a lookup. It finds it in the cluster. And now we can talk to it. So now what I can do is curl on localhost. And then we do port 10,000. And it works. Right? Mainly because we have this label system that will allow us to find anything in the cluster by doing one label query and getting real-time feedback from the node so we can actually introspect it. You can also run Adhoc Commands in these systems. So we can do kubectl exec, and we pick our pod, and we can give it a specific container we want to execute in. So here we'll say our pod, and we want to talk to the Redis container, and we want to run a command in there. So I'll just run uname -all. So we look up the pod, then we enter the namespace of the container Redis, and we output this. So we can introspect these systems. We can also get the logs if we were so inclined. So we can grab the logs for this particular pod. So I'm going to follow the logs for this pod, and we want Redis. So we can actually monitor the logs. So if you're having a production issue, you can take a thing out of the service loop, have it online, and do all your introspection. When you're done, you can actually add a label and bring it back to the cluster. So that's what the Kubernetes API gives you, and this is why all of the components are split up in the way they are, because there's tons of controllers that handle all of these interactions for us. But that's just automated deployment, right? That's not the value of these systems alone. This is par for course. How many people have fully automated infrastructures? Damn! Like one guy. Fully automated, like one-click deploy? Woo! That's a bold claim. Clap for this guy, please. Half the people like, he is lying his ass off.
Hey, PK is hard.
Okay. So, for the one-click deploy guy, he believes he doesn't have a problem, right? So, resources are actually a big deal, right? So, I do this example to explain why resource allocation is important. Right? There's a lot of people that have one-click deploys. You guys are very honest. Every other place I went there, like all of them raised their hand. I knew they were lying, but they held it. But even with one-click deploys, you still have an issue. So in the game of Tetris, how many people have played Tetris? All right, the rest of you, terrible childhoods. So in Tetris, we can imagine that we have this board and it's our resources. And each piece represents a workload. And the idea here is that we can use a resource scheduler to optimize our free resources with the jobs that are running. And people that are fully automated, this is, they're at the highest level, and things work really fast. And what they do is they say, all right, we click one button to deploy everything. And they stand back and admire their resource utilization. And it's pretty terrible, right? Like you're just wasting all this space. Usually one app per machine. And this is what it looks like. You go out for beers and you come back, and then things are out of memory, right? And it's because automating things isn't the whole game, right? You want something online that will actually try to figure out and reason about what resources are available. So what we really want is to have a resource scheduler that will actually do this for us. So we play the game with our eyes open. Now things will go a little bit slower. And what we have to do is we have to figure out and make decisions. So in most of these systems, we do bin packing. So you'll notice that I'm reserving some space to the right, and I'm reserving it for the right piece to show up. And a lot of times when people observe systems like this, it's like, this is obviously broken. I have a whole server that's not being used. Damn those HashiCorp guys. But actually, this is actually by design. You do not want to fragment your cluster. If you start spreading your load everywhere, you're going to end up not being able to hold the right piece. And over time, these things will defragment themselves. And the goal with this is to wait till the right pieces show up, and we'll keep going. So this is your cluster hard at work. And when the final piece comes in, you'll have room for it. And that's an optimized scheduler here. Now, all the greenfield people will say, well, you can't do this in brownfield. What does it look like in brownfield? So if you were to take Nomad or Kubernetes, and you deploy it to your existing cluster, what does that look like for you? You would say, well, we got some Node.js going on. You probably got some like Puppet or Chef going on. So this is your world right now. It's not that bad, right? You're looking good. So if you add these binaries, if you notice, most of these systems, you can drop the binaries right in and have the scheduler start allocating resources and somewhat working around your mess. And over time, if you move more and more workloads to these schedulers, they start to defrag the cluster over time, right? It won't be perfect, but you will end up at least with better resource utilization. And that's how those kind of fit in. And now, how many people work at the enterprise? Man, I'm so sorry for you guys. No, because every time you talk about something new and cool, they're like, what about the enterprise? And I'm like, damn it, dude, like, I don't have your problems. All right, did this thing not break? Damn, this is enterprise. So it's like Oracle did this remotely. Look at that. Larry's like, F you. Well, okay, we may not get to talk about the enterprise right now. All right, we can skip it. Like this timer didn't go, that means I still have 40 minutes. I will take it. I don't know what that's doing. That's enterprise software for you. So once we have these resources, the way we start to decorate our jobs, in Kubernetes what we can do is we can actually describe some quotas. So we have a quota system in place. I think I call this one HashiCorp. And with this one, we are basically have namespaces. So one thing I would like to see in Nomad going forward is the ability to give namespaces out. So I have this large cluster of machines, and I want to delegate portions of those resources to specific development teams. So it would be nice if I had a way of declaring my quota. And these are all hard limits. So in this case, I'm giving out 12 CPUs, 48 gigs of RAM, and I can only run 120 jobs, or pod in this case. So what happens here is there are a couple of things running there using some resources. And if I were to look at limits, so one thing that's also bad, if you were to have tiny jobs come in, you can actually fragment your cluster really bad. So imagine people submitting 120 jobs that only use 1 megabyte of RAM. You end up wasting like 48 gigs of RAM because you allow too tiny of workloads in your system. So what we can do in Kubernetes, we can say that workloads must require 100 megs of RAM, and they must require at least a quarter of a CPU. So with those limits, if we were to look at our pods again, kubectl get pods, one thing I didn't have to do is I didn't have to specify any memory resources. So if I do kubectl describe pods, and we look at one of these pods, we'll see that when I submitted the job, the API server automatically decorated my memory and CPU utilization for me. So the nice thing about this, if your developers do not want to go through the pain or they don't know their sizing requirements, you can actually throw them in there and have it automatically decorate to your policy. And as data gets fed back into the system with Kubernetes, we will support resizing things, meaning we notice that we gave you a gig of RAM and you're not using it, so we're going to bump you down to half a gig of RAM. So now it's time to scale things, right? So what do you do in Nomad? So in Nomad, in order to scale things, and this is a feature I actually like that's really nice. So in Nomad, I can take the same specification, and since I'm using the same name, I can just come down to the count field and increment it to 5. So this is actually pretty nice because for people that manage these things in like Git, I can keep one source of the state and check it in, check it back out, and reason about it. So once I have that updated, I can say nomad run, give it jobs, hello world v1. What am I doing? You guys are letting me fail here. All right. So it notices that we're short 4 allocations, and it goes and schedules the extra jobs and to spread them out the cluster. Even though we can't see the host names here, we do see that they're being spread across the board. This is what I found really, really easy because it is a little bit more cumbersome in other systems to do this. You have to actually know the previous job and go in there and patch it or write a new specification file and replace it. So the nice thing about Nomad is like I can just update that one state and then use it again over and over. So if I check it in, that can remain the permanent state. I think that is a pretty nice feature. And on top of that feature, there's this ability to drain. So let's say you have all of these jobs running in Nomad, and you want to take a server out for maintenance. What do? So there's node status. So each of these nodes are running a collection of I guess, allocations of jobs. So if we were to take one of these nodes, we look at it, we see that this is running 2 of our workload units. What we can do is we can drain this server. And what will happen is Nomad will automatically remove these tasks like a safe failure. The only thing really missing here is lifecycle hooks. So if I know I'm being taken down, I would probably like the opportunity to clean up my connections. So we get these come off, and then you can imagine what should happen. So in Nomad, there's a command called, drain. Forget it, I don't know. And I think it's node drain. So what we can do is node drain, and we give it the node that we care about. So we'll take this one. These IDs, boy. So we've drained this node, and we got to enable it. That's right. So we're going to enable this server to be in drain mode. So once it's in drain mode, we can go back and check the status of this node, and all the jobs on it are stopped. And if I were to show, we look at, we'll do status, and we'll get status of hello. We'll see at the top here that all of our allocations are running. So one of them went dead, and the scheduler rearranges things to make them fit where they need to. So we get all of our things running, and we can actually do this on purpose. In Kubernetes, what we end up with is a timeout. So if a node were to drop off, to prevent flapping in Kubernetes, what we do is we have a 5-minute timeout just to make sure that the machine isn't just rebooting before we move things around. But if it stays down too long, our scheduler will do essentially the same thing. But currently in Kubernetes, there is no way to say, do this right now on purpose. So I think that is a nice feature in Nomad that I would like to see on the other side in Kubernetes. So with that, I'm going to round out the last part around what features you get when you have service discovery built in. So one thing we saw with Kubernetes is that we have a bunch of pods. We have this problem. Each of these pods, if I were to scale them out in Kubernetes world, well, I can actually do this kind of imperative. I can patch the API server and tell it what I want, or I can create a new specification. Here I'm just going to scale. I'm going to scale the replication controller called hello world, and I'm going to give it a new replica count. I'm going to give it 5. So what will happen here, what do you mean you can't find hello world? kubectl git rc. v1. So I'm going to scale this. The nice thing in Kubernetes, there is an event system. So I can say kubectl git events, and we can watch them. So all throughout the system in Kubernetes, we can watch what's happening. So here, I'm saying watch only, and we're going to scale this to 5. And once we do this, we see the scheduler making decisions throughout. Now, the scheduler in Kubernetes is going to be a bit slower because all requests go through the API server, make sure we meet requirements, and also go through a set of emission controllers. So that policy we had that jobs had to be a certain size, those get evaluated. There could be other permissions, like do you even have the ability to deploy in this namespace? Do you even have the ability to pull from this Docker registry? Things like credentials need to make sure that they're actually in place to pull from a private registry. These are things I would like to also see in Nomad. So now that we have these 5 pods, things are scaled up. But we have a problem. We can't actually send traffic to these, right? If you look at these, unless we do port forwarding, these are all on private IPs. So here's where service discovery comes in. With service discovery, what we can do is we can make a service discovery a service in Kubernetes. So it's another object. We'll say we have a service called hello world. We want a high port 36,000, and I'm only do this because I don't have a load balancer in front for this demo. but normally we get a virtual IP that will be available on all machines. If I were to come in on that virtual IP, I would hit this service. For ease of use, I'm going to use port 36,000. And what this selector says is find all the pods that have hello world and send them traffic. So we'll create the service object. So we'll do service, and then we'll do hello world. So once we create this service, it tells us all the machines in your cluster will start intercepting traffic for port 36,000, and they will proxy to the pods that fulfill the service. What are those pods? Well, if we look really quick, if we were to describe the service hello world, we'll see that it does a label query, and today right now we have 5 nodes back there. If we were to scale this again, let's say to 10, the whole system will basically kind of converge on the fact that, hey, once these things become healthy, they'll show up in that backend. So once Redis health check passes, and we describe this again, we'll see there's 3 more now, so there's a total of 6. And as they get healthy, they start to come online. And this is transparent, right? So if you're proxying requests to this, you shouldn't drop any traffic because it tries to do this only when something's healthy. So now that we have this abstraction, let me bump it back down to 5 really quick. I can actually start to examine the state of the system. So let's get rid of our monitoring there. So what we're going to do now is we're going to loop over that public IP. So what I'm going to do is get the list of nodes. So I'm going to list of all my GCE servers, and what I'm going to do is grab one of the Kubernetes nodes. And I know if I hit this public IP on port 36,000, it doesn't matter where the pods are running, it's going to automatically redirect me to one of the pods doing round robin. So what I'm going to do is just do a simple curl so we can actually follow this thing. Let's see if this works. Good. All right, so we're getting hello world, and we're getting version out of it. So once we have this, we can enable another pattern. So once we have APIs to do all this stuff, one pattern that's really popular in this space is to be able to do something called the canary pattern. How many people have used or heard of the canary pattern before? Fantastic. Kubernetes makes it really easy to pull off the canary pattern. What we can do is introduce another replication controller to have a subset of the labels that match the service pool that we have in front. And if you look at this replication controller, we'll call it the canary controller. It looks exactly the same, except for that it runs version 2.0 of the container, same version of Redis, but it does have a different set of labels. The difference here is that it's on track canary instead of track stable. But the nice thing about this is since it's in track app equals hello world, the service proxy will pick it up automatically and send traffic to both controllers. So kubectl create -f canary. Hello canary. So once I create this, the replication controller will notice that there's no pod there that fulfills that request. It'll spin one up, and what will happen is if we look at our traffic and what the customer is monitoring, when it becomes healthy, we'll see our canary pop in, right? And if everything checks out in this pattern, what you normally want to do is let that run for a while, and once you're happy with the results, you want to roll the cluster forward. So ideally, we want to manipulate the V1 controller with a new specification. So in order to do this, we'll look at a new controller. So this is one thing that can be a bit painful is the fact that we need to replace this, especially if we have multiple containers in a pod. But what it looks like is we'll have hello world v2. And this is a common pattern that we see in the Kubernetes world. So this v2 controller looks a lot like the other one. And we have a replica set because maybe your app is more efficient. You may want to bring this replica count down. Maybe you bring it up. And it also has 2.0 across the board. But notice its labels. This one's going to step in and replace the stable controller. So what I can do here is kubectl. Hopefully I have this in my history. Fail. I do not want to type this command. So kubectl rolling -update. And what we want to do now is tell it what our update period is. So update period. And this is the nice thing about Nomad. It allows you to put this in the specification for the job itself. Yeah. So I'm going to do this one for, let's say, let's do 500 milliseconds. I'm going to do this update period. And what I want to do is I want to update a replication controller called hello world. So first I'm going to give it the replacement. So hello world v2. And then I'm going to give it the controller I want to replace. So hello world, v1. So this will go out and search for v1, and we're going to turn v1 down 1 notch and turn v2 up 1 notch until we roll the cluster. So as we run this command, we'll see things get taken down. They go through a lifecycle phase where you get to clean up after yourself. Once your lifecycle hooks return, they're taken out of the loop and they get marked as unhealthy, and they don't show up in the back end. So what we're doing now is just turning the knob up and down on both controllers until we're complete. And what the customer sees is this, right? We're not dropping any packets because we try to do this at the right moment. If you have something like Nginx or HI proxy in front, it should front some of the things that fail and retry another pod in the group. And what we'll see is that they'll have 2.0 over time as this thing rolls. So right now we have 2 more replicas to recycle. And what will happen is at the end, we'll delete hello world v1, and we'll all be running on hello world v2. So basically doing this atomic state change where we're taking one controller and replacing it with another. And over time, this will complete, and we'll have 2.0 across the cluster. Complete. You got to will it. There we go. So once that's complete, and this is what you should see on the other side. The last 1.0 makes it through, and now we're complete. What is this 1.0 in there? Bonus points to anyone that knows why it's still there. Exactly. Fantastic. You guys are good. You guys are paying attention. You guys get it. So in this pod layout, which one is probably the oldest? It's probably this one. It still has a matching label. So track got removed, but the proxy only cared about app equals hello world, so it gets traffic as well. So if you wanted to pull it out of that balancer, you can either delete it, or you can remove another label. So let's delete pods. How do we know this is the right one? We can just bring down production, right? Like my bad, man. Let's see if that works. All right, so we're 2.0 across the board. And with that, I end my demo. Thank you. I am mad the enterprise, like, this is bad. All right, any questions?
We got a few minutes for questions. We got a microphone over here if you want to ask.
Zero questions.
Who wants to be first?
This guy, fantastic.
All right.
So, is Nomad actually running? Because I haven't really seen a demo.
Is it running?
Yeah, like.
You think I was just faking it the whole time?
Yeah. Can you actually access the application in it?
Yes. Oh, let's talk about when you don't have service discovery. Fantastic question. So this is what life looks like when you don't have service discovery. It's really bad. So let's do glist, right? So when you don't have service discovery, you have to go on egg hunt, right? So you look at all your nodes, you're like, okay, I have no idea where these things are. I do have a hint that it's probably one of those 3 at the bottom. So what you can do is, let's see, gcloud, compute. This is what some people are doing. This is service discovery too, right? Like I am literally trying to discover my services. And this is why I don't care how you slice it, you have to have service discovery when you're dealing with systems like this. It just doesn't work. So you're gonna have people writing a bunch of Docker PS scripts. So yeah, good, I found it. So there's my hello world right there, all right? And the fact that I had that issue with the port remapping, I also am now stuck with this private IP. Now, that was a small bug. So if that bug wasn't there, what you would see here is the normal Docker pattern, the -P to give me a high port to map to this one. Right. So that's what will happen. But this is why, without a doubt, Nomad will have to have like console integration, because this shouldn't be a thing. You shouldn't be going on the host to look for your particular applications.
Cool.
I knew you were looking forward to that, but no.
All right, thanks.
All right. How well does Kubernetes scale is the question. So what was this versus thing? It said like 100 nodes, right? We saw this thing? Forget it. So the versus said 100 nodes. So when Kubernetes was launching, Google standards are really, really high, right? Have you ever seen the end-to-end test? It's ridiculous. Like 100 iterations of end-to-end, and it must pass, then it can be cut as a release, right? The first thing we wanted to do was to make sure the API was solid. And in order to do that, we made a lot of compromises on how we handle indexing data inside of the data store. So the biggest limitation to a system like this is going to be the data store. Right now, etcd v2 is not that efficient, right? Samsung has got 1,000 nodes running on Kubernetes. But the SLA that Google's going to tell you is 100 nodes. If we say, yeah, it scales infinitely, like I will totally break Nomad in 3 nodes, right? I can do it really easy, just like I did in this demo. What does it mean to have 100 nodes? What is the SLA around 100 nodes? Will my network performance be there? Will the scheduler still be fast if I go over 100 nodes? So when some people say, well, it scales, like, well, what is your SLAs? Do you want the scheduling to be slow? So in order to make the scheduling fast, we have to optimize things that, what do we store in the store? All events, some events? Does everything need to go through consensus? So today, we say the SLA that we want to meet is 100 nodes. October 15th-ish, we're going to bump that to 1,000 nodes. The goal we want is around 10,000 nodes. If you're putting more than 10,000 nodes in one failure domain, you're going to have a serious problem, right? There's other issues to deal with than just scheduling, right? There's network latencies, lack of resources. If you're doing layer 2 networking, you're going to have your switches fall over from all the ARPs from your containers. There's tons of things to consider when you're doing these things. So more than likely, you will probably have multiple Kubernetes clusters depending on your failure domain. So if you're in Amazon, most people will probably have one Kubernetes cluster per availability zone. Having these things span those particular boundaries, you're going to have latency issues. I guarantee you, at a certain scale, you're going to have latency issues. Good question.
You demonstrated at the end with Kubernetes replication controller, memory tracking, and the rolling upgrade. Are those not yet in Nomad, or they're not there?
Yeah, so Nomad has it, right? So Nomad does it slightly differently. So what we saw with Nomad is that when you create your specification, what is this place? HashiCorp. That's how I do it, man. All right, so in Nomad, you actually put that kind of logic inside of the actual job. So if we look at our job, we actually specify how we want updates to be handled, right? So this encapsulates everything about the job. I do like that feature because it kind of puts it front and center in your intent. But I do like the way Kubernetes does it as well. So Kubernetes, there's a new way we will be doing this in the next release that comes out, maybe a release or 2. But we will actually move all of this deployment logic into a different deployment controller. So the idea there is that you would submit the fact that you want to do a rolling update, and you will submit it to its own independent controller, and it will handle the orchestration of ensuring that happens so you can close your laptop and leave. And then you can check in on your deployment, which is different than scheduling a job, right? Deployment controllers talk to schedulers to give them things that they should be doing, but never do you talk to the scheduler directly, because deployment means a lot of things, right? People will make custom controllers. If you're doing an update on MongoDB, you're gonna have to orchestrate that. It's not about scheduling in the database. There's orchestration involved in that. Good question.
So would you say scheduling and deployment concerns are maybe still tied together, like in Marathon for Nomad, versus it's kind of separated out of Kubernetes?
For my thing, I think a lot of things are coupled here, right? This idea of staggering updates, those might be 2 different concerns, right? As an admin, I may go and want to manipulate the state in the system independent of the task or job, right? Today, they're together. So unless these things were decoupled, if someone staged something in GitHub and I just want to do a rolling update, what do I need to do now? Do I need to back that back to whatever release is currently in production? How do I find out what's currently in production? Because all I want to do at this point, I just want to roll the cluster, right? There could be an issue. So I think in the long term, those will have to be decoupled for certain use cases, right? But remember, it's 0.1. So I think ideally, I've been filing a bunch of issues on GitHub. Every time I run into some small issue, I follow it on GitHub, and everyone's been pretty responsive so far. It's like, yep, we get it, 0.1. And I plan to submit some code, so yep. Any other questions? How many people plan on using Nomad? Awesome. Cool.
All right, thanks for your questions. So we've got about a short break since your awesome demo took a while.
Thank you.
Thank you, Kelsey.